Hi everyone, welcome back. And today we are going to see about the transformer on no load conditions. The operation on no load while there is no load on the transformer. A transformer which is to be operated under no load condition. That means there is no electrical load which is connected across the secondary winding of the transformer, because the primary is connected with the source and the secondary is connected with the load, but across the secondary winding there will be no electrical load. Okay, so or it may be an open circuit or it may be an open circuit. So that means that is called a no load condition. So during this no load condition, there is no flow of current across the secondary winding. So when a transformer operates in a no load condition, no current flows in a secondary winding. There is no current flow through the secondary winding, but a small current called no load current. That is indicated by that's denoted by the I naught, which is around 2% to up to 10% of the rated current. It flows in a primary winding for the magnetization purpose. Okay, so this is the schematic diagram. So in primary winding which is connected with the source and the secondary winding is connected with a load. Okay, but unfortunately here the secondary of the winding is kept open. It is nothing but an open circuit. It is an open circuit, so there is no current. So therefore the current through the secondary winding is nothing but zero. The current through the secondary winding is zero because there is no load. However, the primary current which is drawn by the primary winding, which is denoted by I naught, which is used for the magnetization. That is nothing but to produce the flux in order to transfer between the primary and secondary winding through the transformer core. Okay, so here under this no load condition, it has two component. One is magnetizing component, or it is nothing but a reactive component, and another one is power component, or it may be called as active component, or it may be called as working component. Okay, so it is responsible for setting up the magnetic flux in the core, which is used to set up the magnetic flux in the core. And this component of no load current, it always lag the supply voltage by the angle of 90 degree. But the active component which is responsible for supplying the core losses like iron losses and the copper loss. But here it will be in phase with the either. So therefore the no load current, which is equal to the magnetizing current plus the working component, active component, or it may be called as power component. Okay, so here this is the phasor diagram. So in this phasor diagram, so first of all we can draw the flux line. Okay, so first before, and V1, the V1 is nothing but this is the supply voltage to the primary winding. Okay, so because of this supply winding to the primary winding, it induces flux. The induced flux is always 90 degree lag with respect to the supply voltage. The flux is 90 degree lag with respect to the supply voltage, and the produced flux is circulated through the transformer core and which is inducing the voltage in the primary. That is nothing but induced voltage in the primary, and as well as that same flux which is inducing the voltage in the secondary. So here the both induced voltage E1 and E2 both are in phase, both are equal under no load conditions. Okay, so it is just opposite to the supply voltage. Okay, and so during the no load operation, the current which is drawn by the primary winding is nothing but no load current is nothing but I naught. So here this is nothing but IM. IM is nothing but magnetizing current. So the magnetizing current which is used to produce the flux, so the Im and pi both are in phase, and the working component and the supply voltage both are in phase, and this is the resultant current, okay, the resultant current of the primary winding under no load conditions, okay. So this is the phasor diagram. And this is an assessment in a transformer on load. The total primary current is given by, okay, load component of secondary current, sum of magnetizing current and reflected load current on primary side, reflected load current on primary side, magnetizing current. So put your answer in the comment section, and these are the few references.